All right, guys, this is going to be the video for homework 22, which is going to wrap us up. Final homework for the semester. This one's going over inequalities. The good news is you probably already know what these are. We just have to get to the graphing portion. Main piece here being unequal. When we say inequality, what we're talking about are these guys here. You know what this is, greater than, less than, right? We've done this before, or you've done this before. Greater than, less than. All right. Now be careful, because the first thing people like to do is to say, well, that's greater than and that's less than. It's the same thing. They're both the same sign. So when I say greater than, less than, I'm saying them interchangeably. It depends on how you read it, right? If we wrote something like this, you could definitely say that 3 is greater than 2. And that's because the mouth is toward the 3, just like you were taught back in, I don't know, whatever, second grade. You know, we hear that very early on. It's still true. And you could say that 2 is less than 3. I'm going to be abbreviating a lot. GTLT, greater than, less than, right? 3 is greater than 2, but 2 is less than 3. And you can say this both ways, and both are correct. So you got to be a little bit careful here about how you read this. You don't just read these left to right. If you read it left to right, then yes, that's greater than and that's less than. But we don't read these left to right. We read them from the variable. You'll see what I mean in just a minute. Before we get there, though, there is 2 other signs you should know. You probably do know them. That's greater than, less than, greater than, less than, or equal to, right? If the bar is under them, then there is inclusivity. Like if you said greater than 7, you mean 8, 9, 10, 11, and all that. If you say greater than or equal to 7, you mean 7, 8, 9, 10, and all those kind of things. So just be aware, you know, there is a difference between greater than and greater than or equal to, less than or equal to, all right? The main deal with this homework is taking, or the first half of it anyway, the second half is graphing, is to take inequalities and put them on number lines, basically, all right? So something like this, just something straight up like that, they might just say, you know, go ahead and put that on a number line. If you're having trouble with these, go ahead and write it out in words. X is greater than or equal to 7. Right? That's what that says. If you're having trouble with these, greater than or equal, just abbreviating, to write it out in words, because that's how your brain processes information. All right? And then what they're going to do is give you some number lines. Now, I'm going to be drawing the number lines myself. You guys will just be choosing from some pre-existing number lines, but same idea. We got 0 here, maybe 7 there, and -7 there, right? And what they're going to ask you to do is to represent what you just said on a number line. You said X is greater than or equal to 7. So we're starting at 7 right here. And it's greater than 7. Which means, you know, to the right, because if we go to the left, the numbers get smaller. So we're going to go to the right. And there we go. There's our graph. Except we're missing one thing here. So take a minute, make sure you're cool with that. X is greater than or equal to 7. So we started the 7 and everything greater. The problem is it said greater than or equal to 7. We need to show that. So another thing you probably already know, but just in case you don't, on a number line, if it's greater than or less than, it will be an open circle. On a number line, if it's greater than, less than, or equal to, it will be a closed circle, like a filled in shaded circle. So be aware of that. So on this one where it says X is greater than or equal to 7, it would be a filled in closed circle as 7 to indicate that 7 is included. We would use an open circle to indicate that 7 is not included, all right? Just to give you a counter example to that, let's say over here, and this is what I meant about reading them from the variable. Let's say it said something like this, all right? Now that does say 3 is greater than X, but like I said just a moment ago, I'm gonna go ahead and write it up here. You wanna read from the variable, because that's what we're talking about. We're asking you about X, I'm not asking you about 3. Telling me about 3 is good, but I wanna know about X. That says 3 is greater than X, but if we read it from the variable, it says X is less than 3, because the mouth is not toward the X. So if the 3 is greater than the X, which it is, then that means the X is less than 3, and that's the key point here. So on the number line, just like we did a minute ago, again, y'all will just pick one, but I would suggest drawing your own, just to give you a little better understanding. You got 0, that didn't show well. You got 0, 3, and -3. We're starting at 3. And we said X is less than 3. Numbers get smaller as they go to the left, so the shading would be to the left. And there would be an open circle at 3 to indicate that 3 is not included, right? We said X is less than 3, so 3 itself is not included, whereas over here, we said X was greater than or equal to 7, and it was included. So take just a minute, brush up on all the basics, and then we'll get going with some of the more, I don't want to say advanced stuff, but some of the Like I said, as always, you can pause this at any time. So what we're going to be doing with it, like I said, for the first half of the homework is just translating. So there'll be some that are given to you straight up like that one. There will be some where you'll have to do a little bit of solving. Something like this, maybe. Let's say solve and graph. You will have to graph it when you're done. Something like this. X minus 5 is greater than 3. Just something like that. I mean, it doesn't really matter, right? So it's, you know, it's no different than what we were doing a unit or two ago and we had to solve there. You simply just got to get X by itself. So probably the easiest thing to do here is add 5 to both sides. X on the left side, the 5s are gone. Keep your sign, and 3 plus 5 is 8, and that's your solution. Now the question is, how do you graph it? Well, the same way we just graphed them a minute. Well, excuse me, the same way we just graphed them a minute ago. You just have to solve it first. So here's your number line. Again, not the greatest drawer here. We got 8 and -8, just because I like to know where my negatives are, so it gives me a sense of direction. We said we were starting at 8. X is greater than 8, so that'll be to the right. And if it'll be an open circle or closed circle is our last decision. This says X is greater than 8. So open circle to imply that 8 is not included. Again, take a minute, make sure you're cool with this because, you know, at this point, it's just more a review on solving, honestly. The only thing new here really is just that graphing on the number line, okay? Now, there is one other rule, which we'll get to right now. I just didn't want to kind of throw everything at you at once. Let's say we had to solve something like this. -5x minus 14 is greater than 21. Just whatever, something like that. So same idea. How would you solve it? The same way you solve anything else. You go ahead and get X by itself, maybe add 14 to both sides, right? So now we have -5x. 21 plus 14 is 35, and you just bring the sign down. I mean, these solve just like they said equals, right? It solves just like it says -5 minus 14 equals 21. Just like over here, we added 5 to both sides, just like we would if it was an equal sign. The difference here is what's about to happen now. We need to get the -5 off of the X, as you know, so we're going to divide by -5, divide by -5. So we have X on the left side. 35 divided by -5 is -7. And this time, the inequality sign is going to flip around. Now, why did that happen? Well, think about it for just a second, right? Think back to the early example where I said, that's 3 is greater than 2, right? And that's obviously true. What if I made the signs negative? Which one's greater now? Well, -2 is greater than -3, isn't it? So when you switch signs, and I'll say it more specifically in a minute, but when you switch signs, the inequality is going to flip. Now, how do you switch signs, though? How do you go from positive to negative? By dividing or multiplying by a negative. So that's the other key rule here. It doesn't pop up a lot like over here. We just added 5, no big deal. But if you, and it's multiply or divide, actually. If you divide or multiply by a negative, we just don't multiply by negatives very often in this class. It is possible. If you divide or multiply by a negative, the inequality must flip. Sorry, no, let me rephrase. The inequality sign must flip. Not the whole inequality. Don't spin the thing on a like it's on a signpost. Just that inequality sign would flip. Again, that did not happen here because we just added 5. There was no division or multiplication at all. Here we added 14. There's no need to flip the sign for that. Once we divide by -5, though, I need to flip that inequality sign, so be careful. All right, and then real quick, we'll do the number line. But this is no big deal. Like I said, again, hopefully you've done this before and you're just reviewing right now. So X is less than -7, so that'll be -7 and everything to the left because it's less. And there would be an open circle at -7 because once again, it is less than -7, not less than or equal to. All right, so just take a minute, make sure you're okay with this. The other big rule is if you divide or multiply by a negative, the inequality sign will flip. That's really the only thing different here other than the number line. All right, now where this can get a little tricky and a little bit weird is what we call compound inequalities. These you may not have seen before, so this part might be new to you. It just depends. It's not really a big deal. It's just a matter of getting comfortable with how they look. So something like this. There's not a ton of these in the homework, so we don't need to spend 1,000 years on it. -1 is less than 2x plus 3, which is less than or equal to 9. Something like that, all right? And they're going to tell you to solve it just like we did the other one. Now the thing here is notice there's 3 inequalities. You got 2x plus 3. That's the main object, right? Remember, like we said, you read it from the variable. So 2x plus 3 is at the same time greater than -1, right? 2x plus 3 is greater than -1, and 2x plus 3 is less than or equal to 9. It's saying both at the same time. So if you wanted to write this out in a sentence, it would actually require two different statements. So the way you solve these, the nice thing is your answer just needs to stay, x needs to stay in the middle. You're gonna have a number on one side, x in the middle, and a number on the other. Nice and simple, so just keep x in the middle. That's the main idea here. And the mouths, as I guess we could call them, need to be facing that way. So the good news is they already are, so this should be pretty trivial. The trick here is if these throw you off, cover up one side and just say, all right, what would I do if I needed to solve this? If I needed to get x by itself here, what would we do? We just subtract 3 from both sides, right? Well, just do it to the third side as well then, right? That's the thing here. The compound inequalities, the three-way inequalities, it just means that what you do to one side, you got to do to all three sides rather than just two. And again, remember, we're trying to keep x in the middle. So -1 minus 3, that's -4. In the middle, we have 2x. And over here, 9 minus 3 is 6. Now here's the question. Should the inequality signs flip? Remember what we said just a minute ago. We said if you divide or multiply by a negative, the inequality sign must flip. Well, I didn't divide, did I? There is a negative, right? I subtracted 3 from both sides, or all three sides rather, but I did not divide by a negative. There is a negative, but it's a subtraction. So because we didn't divide by a negative, the signs just stay the same. Now here I'm gonna divide to get x by itself, right? I'm gonna divide by 2. But again, I'm not dividing by a negative, I'm dividing by a positive, so the signs are not gonna flip. -4 divided by 2 is -2. Keep the sign the same because again, we divided by a positive number, not a negative number. X in the middle, just like we want it. And 6 divided by 2 is 3. And that is your solution to the problem. Now we still have to, evaluate it on a number line, but that's the solution. The cool thing about these is on the number line, those two numbers you just stuck x between are literally where x is between. We got -2 over here. We got 3 here, and maybe 0 in the middle. And you said that x was between -2 and 3. So it's simply a matter of finding the one where the shading is between the two numbers. Now, watch the ends again. X is greater than -2, so open circle there. X is less than or equal to 3, so closed circle there. And that's what that would look like. They don't have to match. You don't have to have open circles on both ends or closed circles on both ends or anything like that. So take a minute, make sure you're cool with the solving and the number line stuff, because now we're about to move into the graphing, which is sort of where it all wraps up. All right, so let's go ahead and move on to the graphing, because that is sort of the point here. Again, everything goes back to graphing toward the end of this class. So what we're gonna end up with here, and this will be the final thing we cover in this class, is graphing inequalities. So let me make sure that's just zoomed in. This is the issue I had before. This thing was not picking these graphs up very well. It's about the best it's gonna do, I think. Let's see if we can get this more in picture. There we go. All right, so we're gonna be graphing with inequalities. So for example, just right off the bat, let's say I gave you something like that. Now think about how you'd read that, because I did say read from the variable, right? And there's two variables here. So think about which variable you're reading from, and it's probably the y, yeah, because y equals mx plus b. So that says y is greater than 2x plus 3. What would it look like if it just said y equals 2x plus 3? Forget the greater than, less than for a second. Let's just think about what that would look like. It would start at 3, right? 1, 2, 3. And then the slope would be 2, or 2 over 1 if you want to think about it. So up 2 over 1, up 2 over 1. You guys have seen me do this a lot. You're probably sick of it. And that's where our line would be, right? And then again, down to left 1. If we wanted to go the other way, we would do something like this. Now, I'm not filling the line in for a reason here, but we'll get to that in a second. So that's where your line would be, right? It'd be a nice solid line right there. Y equals 2x plus 3. But here's the thing. It's not y equals 2x plus 3. It's y is greater than 2x plus 3. So you've got this line here, 2x plus 3. And I want to know where the y's, think about what I said there, the y values, which is up and down, is greater than the 2x plus 3. So 2x plus 3 is this line. Wouldn't a greater than here, meaning y's, wouldn't that be above? Y's go up and down, right? So if I said I want to see the y's that are greater than the line, don't I mean above? So what you're going to do here is shade. Now y'all have this little like cute paint bucket tool on the computer that'll do it for you, but that's what you're going to do. You're going to shade above the line because that's what the question asked. Where is y greater than the line? Now the only other thing you got to watch here is the line itself, because I didn't say it's greater than or equal to, right? Remember, there's a difference. We have greater than or less than, and then we have greater than or equal to, less than or equal to, right? If it's greater than or less than, the line is not included. It's just like having an open circle, right? So what we do on a graph is use a dashed line. So what your line would look like is this, actually. And this is why I didn't fill it in earlier. If it was greater than or equal to, less than or equal to, it would be the same as having a closed circle, and then you would use a solid line, because then we would be saying that the y is greater than or equal to the line, right? This time we said y is greater than the line. So here's your line, just graph just like normal, started at 3, went up 2 over 1, up 2 over 1. So the way I got this line is the same way I graph any other y equals mx plus b. Then I said, well, it says y is greater than the line, so that would be above, so I shaded above. And then I said, well, what about the line itself? Well, y was greater than the line, not including the line, so I would use a dashed, all right? Does that hopefully make some sense? Let's do another one real quick. Let's do y is less than or equal to negative 4x minus 3, something like that, all right? So again, hopefully one that you're not, that's pretty comfortable with graphing. So we're gonna start down here at negative 3, 1, 2, 3. And the slope is negative 4 over 1, so you know what that means. That means we're going to go down 1, 2, 3, 4 over 1, down 1, 2, 3, 4 over 1, up, if we want to go the other direction, up 1, 2, 3, 4, and left 1. Just reverse it, up 1, 2, 3, 4, left 1, up 1, 2, 3, 4, left 1, something like that, right? And there would be our line. Now, the question is the line included or not? Well, this said y is less than or equal to negative 4x minus 3. So if it says less than or greater than or equal to, you're just using a solid line, just like always. So we'll go ahead and just draw our line here, nice and solid, just like always. Whoops. Again, there's my great line skills there. All right. Now the question is it above or below? Well, read it again. Y is less than or equal to negative 4x minus 3. Negative 4x minus 3 is the line, right? The question is y is less than or equal to it. So that is below, because it's less than. And as y's get smaller, then they go below, right? Because remember, again, we're not talking x's. We're not talking left and right like on a number line. We're talking up and we're talking down, because we're talking about y's. So if it says y is less than or equal to the line, then you're below the line. Go to the line and just shade below it, which again, y'all can just use the little computer paint bucket for. You don't have to sit there and scribble annoyingly. So hopefully that's making some sense. We'll do one more here, but it's really just graphing a line. The only things you got to remember is the line dashed or is the line solid. And then if it's less than, it'll be below the line. If it's greater than, it'll be above the line. So that's really the only thing you have to be concerned with. So let's do one more here. Not a big deal. It's just maybe one of the more challenging ones. Let's get another graph out here. So let's say you were asked to graph something like 5x minus 4y is greater than or equal to 20, all right? Now, the thing is here, obviously, this is not in y equals mx plus b. So that's the only really other thing that could mess you up is getting this in y equals mx plus b. We'll go ahead and do that over here. I'm probably just going to scribble on top of this graph, and we'll do the actual graphing on this one. So to get this into y equals mx plus b, first thing I would do is subtract 5x from both sides. So that would leave me with negative 4y, right, because the 5x would cancel, is greater than or equal to, and remember, we're trying to make mx plus b, so put the mx part first. All right, so now we have negative 4y is greater than or equal to negative 5x plus 20, because we subtracted the 5x from both sides. I need to get that y by itself, so I need to do what? Go ahead and divide by negative 4. Just make sure you do it everywhere, okay? Now, think about what I just said. You should already be kind of, something should be going off in your head here. So negative 4 cancels, we're left with just y. Negative 5 over negative 4, that's positive 5 over 4x. And 20 divided by negative 4 is negative 5, right? Why am I skipping over the sign here? Well, didn't we divide by a negative? I divided by negative 4, which means my inequality sign needs to flip. So in the end, this is what this looks like when we get it into y equals mx plus b. Again, by now, that should be pretty comfortable to you, but just in case, there it is. And then we just got to graph it. So we got a y-intercept of negative 5, negative 1, 2, 3, 4, 5. We have a slope of 5 over 4. So that's up 1, 2, 3, 4, 5, right? 1, 2, 3, 4. Again, you can do it as many times as you need to if you're doing it by hand. Up 1, 2, 3, 4, 5, over 1, 2, 3, 4. And if we want to go the other direction, down 1, 2, 3, 4, 5, left 1, 2, 3, 4. All right. Now, before you draw your line, decide if it's going to be solid or dotted. This says y is less than or equal to the line, so it is going to be solid. So this will just be a normal solid line here. And then the last thing you need to decide is if it shades above or below. Well, this says y is less than or equal to the line. Less than with y's means below, because we are, again, y's do go up and down, so we are talking below. So you simply come over to your graph, find the graph, and shade everything below it. That's probably going to ruin my marker doing that, but that's all right. This is the last video. We don't care, do we? So there's the graph. So make sure you're okay with that, and that's going to wrap it up, guys. It's just a matter of knowing how to graph y equals mx plus b. You simply have to think about whether the line is dashed or solid, and then whether you're shading above or below. And I will not see you guys in the next one.